from the Curiosity rover of a surprisingly high level of methane on the red planet Mars, possibly a sign of life.
The red dust of Mars whispers secrets. For years, our robotic emissaries have tirelessly roamed its desolate surface, uncovering clues to the planet's ancient past. But what if these clues point to something more? Something that defies conventional explanations. Something beyond the realm of natural forces. Join us on a journey of discovery as we delve into the enigmatic findings of the Martian rovers. Where does the line blur between the extraordinary and the impossible? Let's find out. Mars hints at a past civilization. The Mars rover Perseverance has uncovered discoveries that have sparked speculation about the red planet's past, leading to questions that even prominent thinkers, like the Koenigsegg CEO, can't ignore. Among the findings are complex organic molecules embedded in sedimentary rocks found in the ancient Jezero crater. These molecules are the building blocks of life as we know it, and their complexity hints at a dynamic, life-friendly environment billions of years ago. While not definitive proof of life, their discovery challenges us to rethink what Mars might have been in its distant past. Could these molecules be remnants of something more than just simple chemistry? Jezero crater, once a massive lake and river delta around 3.5 billion years ago, is now the focal point of this thrilling mystery. Scientists chose this location because of its ability to preserve ancient sediments and potentially fossilized remains. Layers of clay and sulfate salts found in the crater point to Mars's watery past, as these materials form in wet environments and are excellent at trapping organic compounds. The combination of organic molecules and the crater's ancient lakebed suggests an environment that might have supported life, even if it was only microbial. What makes these discoveries so shocking isn't simply that organic compounds exist. Rather, it was the place where they were found. These molecules were found in rocks that might have stored up what would have looked like fossils on Earth of all those forms of life long before. That ancient environment of Mars pouring rivers, and rich sediments must have been a wonderful place for overlapping organisms. Indeed, it brings great reflections on whether Mars was more alive than when Earth was struggling to form its first life forms. All discoveries by Perseverance have been a big leap in unraveling what Mars held in its past, but they still leave fascinating, almost seductive questions. If these molecules pour evidence towards life, where has life ingressed? The transition from a hydrous, habitable planet to that across which clouds glitter over an icy desert is indicative of some sort of global environmental catastrophe. This inquiry could perhaps help us design measures to engineer resilience for Earth's environment as well as inform during its processes. These findings, however, make the best case for imagining that life might exist on still different worlds, such as Europa or Enceladus, and that thus the universe was not quite so empty and, one hopes, much more interconnected than we could conceive. This discovery changes everything. But the next one? It's even bigger. A barren wasteland or a forgotten world. Mars, a cold and dusty wasteland today, wasn't always the barren landscape we know. Billions of years ago, the red planet might have been a thriving world with flowing rivers, massive lakes, and a thicker atmosphere capable of supporting life. Evidence from the Perseverance rover points to Jezero crater, an ancient lakebed, as a site that could have hosted these watery features. This crater is a snapshot of Mars's past, hinting at an ecosystem rich in sediments, nutrients, and the right conditions for life, even if it was microbial. Mars' ancient environment bears striking similarities to early Earth, raising the question, did the two planets share a similar fate before diverging? The Jezero crater tells a story of Mars's vibrant past. This site was chosen for exploration because scientists believe it was once home to a river delta that deposited layers of sediment over millions of years. These sediments are prime locations for preserving organic molecules and potentially even fossilized microbes. Findings of clays and sulfate salts in the crater further solidify the theory that water once flowed abundantly on Mars. These minerals are known to form in wet environments and are excellent at trapping organic compounds, making them invaluable in the search for ancient life. In spite of once being a site with rather lively conditions, Mars went under a swift and dramatic change. One such serious turn of events was caused when the planet lost its magnetic field, leaving it exposed to pure solar winds which stripped away all gaseous elements in its atmosphere and made surface water evaporate or freeze. The end result environmental shift devastated Mars, rendering its surface into that frozen desert, which today could not support life as it is known. It marks the process through which a planet comes to have an extremely dismal history as compared to the sustained vivacity of Earth, which is such a contrast to what could have existed in Mars at one time after balancing ingredients over several billion years. The fall of Mars from a potentially life-sustaining planet to a barren wasteland makes it critical for humanity's lessons. The sudden drastic changes in environmental conditions can serve as a warning about the vulnerability of planetary ecosystems. From this, we could learn valuable lessons to secure the Earth's safety from similar threats hereafter. Mars stands beyond Earth as a symbol of hope. Its history suggests that life may not be the exclusive province of our planet's surface. If Mars at one time hosted forms of life, however simple, it encourages notions that other bodies in this solar system, celestial spheres like Europa or Enceladus, may also have life somewhere beneath their icy shells. Jezero Crater, the heart of the mystery. Jezero Crater has become the centerpiece of the Mars rover Perseverance's mission, and for good reason. Once home to a massive lake and a river delta, this ancient site is a time capsule of Mars's watery past. Scientists selected Jezero Crater as the ideal location for exploration due to its potential to preserve sediments that could hold evidence of life. Around 3.5 billion years ago, this crater was a dynamic ecosystem where rivers carried silt and nutrients, creating the perfect conditions for microbial life. The lake's sediments, now fossilized into layers of rock, provide a glimpse into Mars's ancient environment. One of the most significant discoveries in Jezero Crater is the presence of clays and sulfate salts, minerals that form in the presence of water and are known to trap organic compounds. These findings bolster the theory that this area once had abundant liquid water, a key ingredient for life. Sedimentary rocks in the crater act like natural archives, preserving the chemical and biological history of Mars. If any microbial life existed billions of years ago, its remains may still be hidden in these rocks, waiting to be uncovered by Perseverance's advanced tools. Perseverance has been meticulously analyzing these rocks and soils, trying to find signs of life, and using high-tech instruments like Sherlock. An instrument that employs ultraviolet light to detect complex organic molecules, the rover finds hints of past biological activity. The organic compounds from Jezero that have been discovered are not just the simple ones. They are complex, and may, just as their complexity suggests, have some biological processes associated with them. While they are not yet the ultimate proof of life, these molecules are critical clues indicating that Jezero was once promising for living organisms. In addition to being a window to the past of Mars, the Jezero crater is also a portal into understanding the larger quest for life beyond Earth. Indeed, if organic molecules with their possible microfossils were found here, it would rank as the first direct evidence for life off the planet. This would change the whole contingent view about the potential for life throughout the cosmos. Moreover, these sediments could also be indicative of the evolutionary changes that have taken Mars from the planet it once was, and still could be, wet, habitable world, to the dried-up, deserted one it is today. This is very important in the context of planetary evolution and planning future missions, which might include manned missions to the Red Planet. Complex organic molecules. The discovery of complex organic molecules on Mars is nothing short of groundbreaking. Found within sedimentary rocks in Jezero Crater, these molecules are considered the building blocks of life. Organic compounds are essential for life on Earth, and their presence on Mars hints at a dynamic chemical environment billions of years ago. While these molecules are not definitive proof of life, their complexity goes beyond simple chemistry. raising the possibility that they could be remnants of biological activity. For scientists, this finding is a significant step in unraveling Mars' potential for habitability. What makes these organic molecules truly fascinating is where and how they were found. Perseverance's instruments detected them in sedimentary rocks, which are known for their ability to preserve ancient materials like fossils. These rocks likely formed in a lakebed, where silt and organic material could have accumulated and been trapped over time. This discovery suggests that Mars had the right conditions to support life billions of years ago. On Earth, similar sedimentary environments have been gold mines for uncovering evidence of past life, making the Jezero crater an ideal place for exploration. Notably, the organic molecules discovered by Perseverance are complex rather than simple carbon-based compounds, and give evidence of complex chemistry. Such molecules are typically attributable to biological processes that characterize Earth, but although organics do result from geochemical methods, the complexity seen on Mars hints at a history of chemical interaction that could have microbial actors. It further isolates and confines the argument for additional exploration because the implication is that Mars would have been a habitable planet. The presence of these molecules therefore extends the scope even further into the new search for life beyond Earth. It could bring in questions of producing or retaining organic molecules on some other worlds like Europa or Enceladus, where water has been found and conditions are similar. Thus, Perseverance's findings in Jezero crater would likely tip the balance for astrobiology, since they hint at what seems to be telling secret evidence that Mars may have harbored life in the remote past. Scientists can thus get closer to answering one of the deepest questions ever posed to humanity. Are we alone in the universe? What went wrong? Mars wasn't always the cold, barren wasteland it is today. Billions of years ago, the red planet likely had a thick atmosphere, flowing rivers, and vast lakes, making it a potentially habitable environment. The evidence uncovered by the Perseverance rover suggests that Jezero crater was once home to a thriving lake and a river delta, offering the perfect conditions for life. However, something went catastrophically wrong, transforming Mars from a vibrant, water-rich world into the desolate desert we see today. Understanding this dramatic shift is key to unraveling Mars' history and could offer insights into the fragility of planetary ecosystems. The turning point in Mars's timeline was the loss of its magnetic field, which left the planet vulnerable to the harsh realities of space. Without a magnetic shield to protect it, solar winds, streams of charged particles from the Sun, began stripping away Mars' atmosphere. Over time, this process reduced the atmospheric pressure to a level where liquid water could no longer exist on the surface. Rivers and lakes dried up or froze, and Mars transitioned into the dry, frozen desert it is today. This loss of atmosphere was a death sentence for any potential life forms that may have existed on the planet. Lack of a magnetic field followed by the erosion of atmosphere resulted in cascading effects within Mars's climate. As the atmospheric thinning happened, the temperatures started going down, making the planet inhospitable as per the current definitions of life. This transformation seems to be in stark contrast to Earth, which retained its magnetic field and atmosphere, thus enabling it to flourish with life. The study of Mars's environmental collapse serves as a warning sign about the delicate balance for sustaining life and loses its livelihood in atmospheric loss. What is happening on Mars in this tragic transformation raises much deeper concerns about planetary environmental robustness. Perseverance is one of the few ways through which ancient rocks and sediment are helping scientists reconstruct the chain of incidents that led to Mars's downfall. Those results offer more than insights into what went wrong on Mars. They also provide a warning for Earth. Knowing how Mars lost its qualifications for sustaining life can help humans find ways to insulate their planet from similar threats. These discoveries thus also provide evidence that life could still exist elsewhere in the universe, on worlds that have managed to dodge the outcome which befell the red planet. Mars is turning up the heat. Get ready for the next epic reveal. Are we looking in the right direction? The discovery of complex organic molecules and evidence of a watery past on Mars has profound implications that extend far beyond the red planet. If Mars once harbored the conditions necessary for life, it challenges the notion that life is unique to Earth. Scientists have long speculated about the possibility of life existing elsewhere in the universe, and Mars, as our closest neighbor, has always been central to that question. The findings from the Perseverance rover suggest that life may have emerged in multiple places under similar conditions, making the search for life across the cosmos even more promising. If life once existed on Mars, it raises the question, where else might we find it? Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are considered prime candidates. Both moons have subsurface oceans beneath their icy shells, environments that could potentially support life. The discoveries on Mars provide a roadmap for how to search for life in these distant locations. The methods used by Perseverance to detect organic compounds and ancient sediments can inform future missions to these icy worlds. Mars may just be the first chapter in a larger story about the prevalence of life in our solar system. Mars's history obliges people to consider otherwise the conditions necessary for life to flourish. Organic molecules and water in a protected atmosphere are essential. However, the transformation of Mars into a life-barren wasteland demonstrates the frailty of those conditions. Any initial life on Mars has been eliminated due to the loss of its atmosphere and magnetic fields. Such recognition thus engenders a consideration of the duration of environments rendered habitable, and not only for the initial attachment. Indeed, the lesson learned from Mars serves as guidance for rescripting the rules of planets or moons, which may eventually harbor life for posterity. These implications are philosophical as well as scientific. By contrasting other worlds with the microbe, life as it has been determined up to now is no longer exclusive for the Earth, but can sprout up in worlds outside. The universe may indeed be an eclectic tapestry of diverse life, or not some solitary expanse. Every new find on Mars will bring us closer to answering that age-old question: are we alone? We may never have found direct evidence of other life forms yet, but signs from Mars suggest we may be looking in the right places. Searching for life just begun, and the presence of Mars will prove pivotal for humanity's voyaging of the universe. Perseverance's role in unraveling the mystery. The Perseverance rover is at the forefront of unraveling Mars's ancient mysteries, equipped with some of the most advanced scientific tools ever sent to another planet. Since its landing in Jezero crater in February 2021, Perseverance has been meticulously analyzing rocks, soil, and sediment to search for signs of past life. Its primary mission is to uncover evidence of Mars's watery past and determine if microbial life once existed there. By focusing on Jezero crater, a location believed to have hosted a lake and river delta billions of years ago, Perseverance is exploring a site rich in potential clues about Mars's habitability. One of Perseverance's most remarkable tools is Sherlock, an instrument that uses ultraviolet light to detect organic compounds in rocks. These compounds, often associated with biological activity on Earth, are critical in understanding Mars's past environments. Perseverance's findings so far include complex organic molecules preserved in sedimentary rocks, hinting at a dynamic chemical history. While these discoveries don't confirm life, they are compelling evidence that Mars had the right ingredients for life at one time. The rover's ability to analyze these molecules in detail makes it a crucial asset in the search for life. There are also preparations for the next phase of Mars exploration, with Perseverance collecting samples of rock and soil, sealing them in tubes, and then leaving them on the surface of Mars for a later mission to retrieve and bring them back to Earth. Afterward, the terrestrial laboratories would analyze these samples with scientific techniques that far exceed the capabilities of the rover's onboard instruments. Thus, the returned samples will probably finally answer whether or not Mars has ever hosted life, making this activity by Perseverance crucial in solving this cosmic riddle. No less than those, Perseverance's activities are meant to eventually set the groundwork for human beings who will one day set foot on Mars. The rover's studies of Martian geology, climatic history, and surface conditions provide critical data that could make human missions to Mars much more adaptable to the Martian environment. Perseverance is, therefore, able to make the leap from robotic exploration toward that great dream of humankind, sauntering on the red planet, from learning how Mars lost its atmosphere to identify potential resources that could be exploited by human settlers. Only this time, though, the returns will be in contemporary wonders. Not just the history of Mars, but the future of space travel and ultimately our quest to answer that question. Are we alone in the universe? What if life isn't rare? The discoveries made by the Mars rover Perseverance challenge one of humanity's most profound assumptions, that life is a rarity in the universe. If Mars, our closest planetary neighbor, once had the conditions to support life, liquid water, organic molecules, and a habitable environment, it suggests that life might not be a singular phenomenon exclusive to Earth. This revelation shifts the cosmic perspective, opening the door to the possibility that life could exist on other planets or moons with similar conditions. The idea that life could emerge elsewhere redefines our understanding of the universe and our place within it. Mars's story is a powerful starting point for this broader search. The discovery of organic molecules preserved in sedimentary rocks in Jezero crater suggests that the building blocks of life may be more widespread than previously thought. If these molecules hint at past microbial life on Mars, it means life could arise under the right conditions in other parts of the solar system. Locations like Europa, with its subsurface ocean beneath an icy crust, or Enceladus, with its geysers ejecting water into space, now seem even more promising as candidates for harboring life. This shift in perspective has profound implications for how we search for extraterrestrial life. If life existed on Mars, even in microbial form, it suggests that life could be a common outcome of planetary evolution. The discoveries on Mars inform the strategies used to explore other celestial bodies, guiding future missions to focus on environments with water, organic materials, and protective atmospheres. It also raises the possibility that life might thrive in forms and conditions unlike anything we've encountered, broadening the scope of our exploration efforts. The notion that life isn't rare also prompts a deeper reflection on Earth and the fragile balance that sustains life here. Mars' transition from a potentially habitable world to a barren wasteland serves as a cautionary tale about the vulnerabilities of planetary ecosystems. At the same time, it offers hope that life might emerge, persist, and adapt elsewhere in the cosmos. If life is a common thread in the universe, it transforms our understanding of existence, connecting us to a vast, interconnected tapestry of living worlds. Perseverance's findings may be the first step in uncovering this grander truth, proving that life's spark might be more universal than we ever imagined. Even the discoveries on Mars ignite a thirst for reconsideration regarding the origins of life itself. Considering that there could have been life on Earth and Mars at roughly the same times, one tantalizing prospect is that this life was derived from a common origin. Perhaps life traveled from planet to planet, even possibly by way of meteorites and their activity, or some later cosmic event. Alternatively, one could ask whether life originated independently on both worlds, but by universal principles of chemistry and biology. These questions challenge the scientists' ability to go beyond earthly life models and think about all possibilities for how and where life begins in the universe. The prospects for life, or life's conditions, transcend scientific challenges and portend broad changes in human thinking, culture, and future priorities. If life is not unique to Earth, we have just changed the scenario of discussion from our place in the cosmos to our responsibilities as stewards of life and our role in potentially exploring other worlds. It could foster a more unified global enterprise to care for life on Earth while pursuing it elsewhere. What Perseverance finds is not merely in the past, but calls to action a people renewed in curiosity, humility, and determination in exploring the vast universe. Koenigsegg CEO's take: why it matters. The bold statement by the Koenigsegg CEO that something has been here before encapsulates the excitement and curiosity sparked by the Perseverance rover's findings on Mars. This perspective underscores how groundbreaking discoveries in space exploration resonate beyond the scientific community, capturing the imagination of innovators and visionaries. The CEO's take ties these findings to a larger narrative about humanity's drive to push boundaries, innovate, and explore the unknown. By highlighting the importance of the Mars mission, the CEO challenges us to rethink the possibilities of what might have existed on the red planet. One of the key reasons this matters is the profound implication that life may not be unique to Earth. The discovery of complex organic molecules and evidence of a watery past on Mars suggests that the conditions necessary for life could exist in other parts of the universe. The CEO's perspective aligns with this shift, emphasizing how these findings broaden humanity's understanding of life's potential across the cosmos. For those in industries driven by innovation, such revelations act as a catalyst for new ideas, technologies, and missions aimed at answering the ultimate question: are we alone? The CEO's interpretation also highlights the intersection of science, technology, and human ambition. Perseverance's mission is a testament to what humanity can achieve when combining advanced engineering with an insatiable curiosity to explore. The tools and techniques used to uncover Mars's secrets are not only advancing science, but also inspiring new applications in other fields. From robotics to resource management, the innovations sparked by space exploration have the potential to shape industries and improve life on Earth. This dual impact, advancing both our understanding of the universe and our technological capabilities, makes the Perseverance mission a pivotal moment in human history. Ultimately, the CEO's take emphasizes why the search for life on Mars and beyond matters for everyone. It's not just about finding answers to scientific questions. It's about redefining our place in the universe and inspiring humanity to dream bigger. The possibility that Mars once harbored life, or that other planets could, fuels our collective drive to explore, innovate, and push the boundaries of what's possible. The CEO's statement serves as a reminder that discoveries like those made by Perseverance are more than just data points. They are milestones in humanity's ongoing journey to understand the cosmos and our role within it. And the statement from Koenigsegg CEO serves to rally the people into collaborative efforts across nations and industries. Space exploration has always transcended the boundaries and political divisiveness to bring humanity in searching for knowledge that benefits all of mankind. As reminders of the challenges, hurdles, technical, financial, or scientific, all demand collective ingenuity and a shared vision. Discoveries from Mars suggest that space exploration indeed is a collective endeavor. Stressing these findings, thus, the CEO could affirm that it is through coming together globally that these larger questions related to life, the universe, and our collective future can be put to rest. Mars promises certainly implications that go beyond the globe to generations yet unborn. Life on Mars rekindles interest in the STEM fields of science, technology, engineering, and mathematics that encourage young minds to become curious about and inspired by possibility. These revelations do not end with the current generation and point to the next wave of explorers, innovators, and dreamers who will take up the challenge of realizing the human potential further. This is the moment captured, really, by the CEO's words, the understanding that we are on the brink of understanding something far greater than ourselves, and that will, in turn, shape the future of humanity and our place in the cosmos. The last Mars revelation is here, and trust us, it's worth the wait. What comes next? The discoveries made by the Perseverance rover on Mars mark a pivotal moment in our exploration of the cosmos, but they also leave us with more questions than answers. The presence of complex organic molecules, evidence of ancient water, and sedimentary rocks that could hold fossilized life suggest that Mars was once a thriving environment. Yet, the story of Mars is incomplete. What exactly happened to turn this potentially habitable world into the cold, barren desert it is today? As scientists continue to piece together Mars's history, these unanswered questions drive the urgency of future exploration. One of the most critical next steps is bringing Martian samples back to Earth for detailed analysis. Perseverance has been collecting and sealing rock and soil samples, leaving them on the Martian surface for a future mission to retrieve. These samples could provide definitive proof of whether Mars ever supported life, allowing scientists to conduct tests far beyond the capabilities of the rover's onboard instruments. If life, even in microbial form, is confirmed, it would redefine our understanding of life's prevalence in the universe and suggest that the cosmos might be teeming with life. The implications of these findings go well beyond scientific curiosity. They touch and shape the future and fate of mankind's space explorations. If ever Mars were blessed with these conditions, one possibility that emerges from such scientific inquiry is a future restoration of habitability. Understanding how Mars lost its atmosphere and water might guide us in developing technologies adaptable to such extreme environments, or even reverse part of the changes. This knowledge is critical not just for human settlement on Mars, but also for preserving the Earth's delicate ecosystem. Mars's past serves as both a caution against us and an inspiration for what can be achieved in the future. Looking at the horizon, one thing is for sure. The journey to discover life on Mars is just the beginning. The evidence from Perseverance raises even more hope that there might be possible places such as Europa or Enceladus, where the answer to the age-old question, "Are we alone?" has been lurking. However, everything that can be discovered on Mars constitutes another piece to the puzzle as we get closer to understanding the universe and our place in it. What comes next is not just about Mars, it is about the future of humanity, exploration of the universe, potential life beyond this planet, and of course, future possibilities without end. The search is not scientific alone, but a journey for a united curiosity, inventive thought, and hunger for the way that humans have to know what their place in the cosmos really is. Perseverance's mission reminds us of how far we've come in our exploration of the universe and sets the yardstick for yet so much more to be discovered. Beyond the search for ancient microbes, discoveries push forward what is known of planetary evolution and conditions required for life. With more and more missions in the pipeline, including human exploration of Mars, the lessons learnt will be taken from Perseverance to serve as a basis for building a sustainable presence away from Earth. Thanks for joining us on this incredible journey to uncover the mysteries of Mars. What do you think about the discoveries made by the Perseverance rover? Let us know in the comments below. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell so you never miss out on more fascinating content. And before you go, check out the next video on the screen. It's one you won't want to miss. See you there.